In this video, we will consider the implications of changing setting for the extent of fractionation. It is recommended that you watch this tutorial after watching tutorials on the structure of the output files, as it will be assumed here that you are familiar with the structure of the output files in general. The extent of fractionation is set in this section of the main form for each of the phases which can be present in calculations. In this particular video, we will consider a very simple case where the starting composition has only major elements, which are displayed here, and it doesn't have any trace of volatile elements. Let's add several phases, so I will add plagioclase here and clinopyroxene, and that's enough for the example we want to consider. We will use pure fractional crystallization with fractionation set to 100%. I would like to have pressure at 5 kilobars, and I think that 15% fractionation will be sufficient for our purposes today. Let's start calculation. Calculations will go very quickly, and let's have a look at the results. So the main take-home message here is that when we set fractionation to 100%, we are calculating pure fractional crystallization. The implication is that as soon as minerals formed, they are removed from the magma, removed from the contact with the melt, and they are placed in what we call cumulate. In the real magmatic system, these can be marsh zones or cumulate piles, whatever people like calling those places where crystals accumulate separated from the melt. Once they're separated from the melt, they are not changing their composition remains. So let's have a look at the state of our system after 15% of crystallization. 3 minerals crystallized, but because they're removed from the melt as soon as they're formed, the composition of the magma is only melt. You can see here that we stopped at 85% melt, 15% crystallization. The composition of the melt is exactly the same as the composition of the magma because there are no other phases, and when we list the phases in the magma, the only one here is melt. All the crystals which we formed are in the cumulate. This is the combined composition of all phases in the cumulate. Each of those compositions are the bulk composition of all olivines in the cumulate, all plagioclase crystals, and all clinopyroxene crystals in the cumulate. These are the proportions from the total. So you can see that there are approximately similar values of olivine and plagioclase and a little bit of clinopyroxene because it joined crystallization later than the first two minerals. And again, I would like to draw your attention to the fact that these compositions are different than the compositions which are shown here at the top part of the output, and these are the compositions of the minerals which are currently forming from the melt, where these are combined compositions of all the crystals which formed up to this time. So towards the end of calculation, the difference between these compositions is much larger. So if we have a look at olivine, you can see that the content of iron here is almost 15%, whereas here it's 13%. The implication in terms of phosphorite, it's 86 in the cumulate, whereas it is 84.3 in forming in the magma. And at earlier stages of crystallization, this difference would be less. And this is simply because in the cumulate we are accumulating all the crystals and the further crystallization proceeds, the more difference it is between the composition of the mineral which is currently forming and all the crystals which formed previously. If we load the compositions into Excel to have a look what is actually saved, the important thing to remember that these compositions here, you can see magma is written here, these are the compositions which are forming from the melt at every stage of fractionation that was recorded during calculation. So these are the compositions of plagioclase clay that will be forming at all these different stages of crystallization. Now, in the main output file, which shows compositions of the magma and the melt, when we scroll towards the end, you will see that the percentages for crystals in the magma are zeros, simply because they are not there, and the crystals are in the cumulate. So these are the proportions of the crystals during crystallization. And you can see that clinopyroxene appeared just before the end, so it's present in two last lines of the output, whereas olivine was the first, and then plagioclase joined crystallization some point later. And as we discussed in other videos, if you would like to also export the composition of those phases, how the compositions of individual phases in the cumulate are changing with crystallization, you can do this by going into options and selecting add export of cumulates phases to files. I haven't chosen this for that video, as we discussed all this in videos on the structure of the output files. Now, if we consider the opposite case, when the crystallization is purely in equilibrium, we will put zeros in here instead of 100, so it means that no cumulate is forming. And if we do calculation in this case, what we will see is that there is no cumulate, that crystals are now in the magma, and this type of crystallization leads to crystals continuously re-equilibrating. So the amount of the crystals in the magma is increasing continuously, and their composition is continuously changing. So all olivine, which is present in the magma towards the end, and this is 6.5% of the initial mass, is now the composition of phosphorite 84.65, and those olivines which formed earlier, they had more magnesium, less iron, higher phosphorite. They are re-equilibrating with the melt as crystallization proceeds, becoming more and more iron rich, and all of them have exactly the same composition. So if we import these results into the Excel file, two things I would like to highlight for you. First of all, the composition of cumulate is 0 in the main output file, simply because there are no crystals in the cumulate. And if we go and at the end and have a look at the proportions, the crystals are now in the magma, and there is nothing in the cumulate. So these numbers are now 0, and these columns have numbers because that's where the minerals are. If you do similar calculations on your computer and you can compare the values, they will actually be slightly different, and the compositions of minerals in the magma, which are shown in these sheets, will also be different during equilibrium crystallization and fractional crystallization. In most cases, the most realistic case would be when some crystals are fractionating and some crystals are remaining in the magma, and usually crystals do not fractionate to the same extent. More denser crystals like olivine would fractionate more, so if we put here 80%, that can be a realistic number. Plagioclase would fractionate less. It's difficult to say what the realistic number is, but let's say we assume 50%, and we can put clinopyroxene somewhere in between. And if we perform calculation using now these values, what we will have at the end is that there are crystals in both magma and cumulate. Now you can see in here we have magma and some crystals in the magma present, and then we have cumulate and some proportion of the crystals are present in the cumulate as well. Since we set 50% fractionation for plagioclase, you can see that the amount of plagioclase in the magma and the amount of plagioclase in the cumulate are exactly the same, because that's how we set up the parameters for calculations. And again, as before, these compositions are different. The combined composition in the cumulate is different from the composition of the crystals in the magma. And all plagioclase in the magma has the same composition, all olivine in the magma has the same compositions, but individual crystals present in the cumulate would have different compositions, reflecting the crystallization history. And this composition of the phase in the cumulate represents the combined bulk composition of minerals in the cumulate. If we now import these results to Excel, the only difference we will see with the previous results is that now we have the composition of the cumulate again, and now we have percentages of minerals both present in the magma and in the cumulate. So these are, so to speak, physical implications of changing fractionation settings during calculations. If you would like to conduct calculations with various settings for this parameter extent of crystallization, you can then, looking at the result, assess the implication of these changes. This is the end of this video. If you have any questions, as always, you can email us on support@petrologsoftware.com.